The nervous system is an extremely complex system of chemical interactions that allows human intelligence and most life as we know it to exist. In this presentation, we will be detailing how this system works. The base unit of the nervous system is the nerve cell. Stretching up to 1 meter long, it is in charge of conveying electrical and chemical signals up and down the body. Chemical signals come in through the dendrite, located in the cell body. Signals travel through Schwann cells and across nodes of Ranvier into the axon terminals. Let's now look at a close-up of the membrane of the axon. This would be located near the nodes of Ranvier where the axon is exposed to the extracellular matrix. The membrane is made up of phospholipids separating the outside from the inside. In between the phospholipids is sodium-potassium pumps, sodium channels, and potassium channels. The sodium-potassium pump is in charge of keeping sodium outside of the cell and potassium inside the cell. This creates a charge differential that can be used by the action potential. Action potential is the method of propagating an electrical signal down the length of the axon. Resting membrane potential is -70 millivolts, but in response to a stimuli, depolarization occurs where sodium channels open, causing the charge to become more positive. This is followed by an opening of potassium channels, or repolarization, causing the charge to bring back down to -70 millivolts. This is followed by a slight refractory period where the sodium channels can no longer open. This refractory period causes the action potential to only move one direction down the axon, preventing backward signals. Once the action potential has flowed down the length of the axon, it encounters the synapse, inside of which are synaptic vesicles containing neurotransmitters. The action potential activates calcium channels, which let calcium in, binding to the synaptic vesicles, causing them to form with the presynaptic membrane, releasing neurotransmitters into the synaptic cleft. Unfortunately, sometimes this synaptic process can be hijacked by neurotoxins such as sarin gas. Sarin gas binds to a certain enzyme called acetylcholinesterase, which is in charge of breaking down acetylcholine. Without it, acetylcholine builds up in the synaptic cleft. This tells your motor neurons to continually flex. Without the ability to unflex, the victim eventually succumbs to paralysis and most times death. It is considered a horrific weapon of war and banned in most countries, including the United States. Unfortunately, these regulations do not stop all uses, as the Syrian government was reported using it against its own citizens. On that incredibly happy note, thanks for listening to our presentation.